glucose has an important job. So it's got to come in. How's it going to come in? What?
Facilitated diffusion.
Facilitated diffusion and
Active transport.
active transport. Exactly, because that was secondary active transport along with sodium. All right, sodium is going to be important to come inside the cell because it's going to affect how neurons work. So it's also not going to use the second messenger system. It needs to come in. It may be the goal of the second messenger system is to bring in sodium. So how does sodium get in? Active transport and not simple diffusion. Why not simple diffusion? Got her hanging here. Why not simple diffusion? How come sodium can't cross the non-polar plasma membrane? Because it's polar. Right. All right, what about carbon dioxide? Simple diffusion. It's non-polar. So it just moves in or moves out. Potassium. Again, potassium is going to be important for how neurons work. So how's potassium going to come in?
Active transport.
Active transport and facilitated diffusion. Same as sodium. All right, what about water? Simple diffusion. Individual water cells can shimmy through. But if we really want to move water,
Active transport.
no.
Oh.
Let's pause right here because I heard you say that and I didn't correct you at the time. Water is never actively transported, ever. We don't get many nevers in physiology. Grab that one.
Isn't that like the lab we did yesterday where we stuck so many grams?
Yeah, how'd it move? Passively.
through osmosis?
Yeah, exactly. So that's how a cell moves water is by changing the ion concentration. And then if we put more particles on one side of a membrane than the other, water comes in. We will pump sodium, which will then, water will just move. So water's never actively transported, but it can do simple diffusion, and then what's the other option? Facilitated diffusion. You know, we put it in aquaporin. So if we really want to move water fast, bulk water, we're going to put in a pore. All right, now we have insulin. How does insulin leave the beta cell Langerhans?
Active transport.
Active transport as a vesicle. So the beta cell wraps a vesicle around the insulin that it's making and it keeps it, and then when we need insulin, it just pushes it out, which requires ATP, so it's active. And then once that insulin gets to a target cell, insulin is a hormone, it's a signal molecule. How's it going to communicate? Second messenger system. Yeah, in fact, the tyrosine kinase one. Then we have cortisol. How's cortisol going to move? Simple diffusion, because it is non-polar. There you go.
Simple.
Got some learning happened. Trial and error. Very powerful
Do you want
learning.
these?
Some got some validation. In some ways you were right. Okay, questions about any of that?
Do you want this?
And then I want that. Now remember, it's on the test, so you want to be sure that you know it. Uh-oh. Do you need to write it down on
I'm gonna
something?
make a copy of it.
All right, then we'll go ahead and go to lab. So take a break, finish that up, turn it in, and then we'll go to lab.
Do some marking out.